Hey everyone, welcome back to our data structure tutorial series. I am Akshay and today we are diving into one of the most efficient searching algorithm out here, that is binary search. Trust me, by end of this video you will not only understand binary search but also love how simple and powerful it is. Ready? Let's go. In last video, we have covered linear search algorithm on the unsorted arrays. If you missed my last video on linear search, make sure to check it out by clicking on the info icon above. What exactly is binary search? See, in this picture, you have a sorted list of numbers and you need to find a specific number. Instead of searching one by one like a snail, binary search split the list in half over and over until it finds the number. It is super cool, right? Here is the catch. Binary search work on the sorted arrays only. If your data is not sorted, you need to sort it first. Let's break it down step by step. Step number first. Start with 2 pointers, one at a beginning of the array and one at end. Step number 2. Calculate middle index of the array. Step number 3. Compare middle element with target value. If it is matched, congratulations, you found it. If middle element is greater than target, move the end pointer to the middle -1. If it is smaller, move the start pointer to the middle +1. Step number 4. Repeat this process until find the element or the pointer overlap. It is just 4 steps only, super easy, right? Now let's see this in action with an example. Here are sorted array. Let's find the number 23 using binary search. Initial pointers. Start is equal to 0, end is equal to 9, middle is equal to 0 plus 9 divided by 2, that is 4. Element at index 4 is 16. 23 is greater than 16, so move the start pointer to 5. New middle, that is a 5 plus 9 divided by 2, that is 7. Element at index 7 is 45. 23 is less than 45, so move the end pointer to 6. New middle, that is a 5 plus 6 divided by 2, that is a 5. Element at index 5 is 23. Found it, right? See how simple this was. Instead of checking all 10 elements, we found it in just 3 steps only. Now let's translate this into code. I will show you the implementation in Python and Java. Step number 1, start with 2 pointers. Step number 2, calculate middle index of the array. In step number 3, compare middle element with target value. Step number 4, repeat this process until you find the element or the pointer overlap. This code is simple yet powerful. Feel free to pause and try it out yourself. Before we wrap up, here's when to use binary search. Number 1, your data is sorted. Number 2, you need a fast search solution. Binary search is commonly used in datasets, search engines, and countless algorithms. It's a must-know for every coders. That's it for today's topic on binary search. I hope you found it engaging and easy to follow. If you did, don't forget to like, share, and subscribe for more awesome tutorials. And drop a comment if you have any questions or suggestions for future topics. Until next time, keep coding and stay curious.